All right, in this video, we're going to learn about applying exponential growth and decay. So this week, we've learned how to write an exponential function from a graph and a table. We've learned about what exponential functions are, what they look like when they grow, and what they look like when they decay. So now we're actually going to apply what we've learned. So this is Module 8, Lesson 3. And this is benchmark 5.4 or AR 5.4. We need to write an exponential function to represent the relationship between two quantities from a graph, a written description, or a table of values. So this is where that written description comes into play. So exponential growth, we're going to use the formula y is equal to a multiplied by 1 plus r to the power of t. So obviously we will be adding our rate. So y is our final amount, a is our initial amount, r is the rate that we are growing, and t is the amount of time that we have to allow that rate to grow. So in your notes it says growth rate. That was a mistake. It should be called the growth factor. So please cross that out and rewrite growth factor. Now, remember how to convert a percentage to a decimal? It may seem silly, but it's something that students often make a mistake with. So if you have 2.5%, your rate is not 2.5, it is going to be 0.025. So we have to remember to shift that decimal point 2 places to the left. So our rate, if we're given a percent, is actually going to be 0.025. So just something to take note of, because a lot of times with our word problems, we're given a percent, but we have to remember to convert that to a decimal. All right. So if you can't remember, if you forget how to move the decimal or which way to move the decimal, you can also take the number, the percentage, 2.5, and divide it by 100, and then that would give you the decimal as well. All right. So in our first example, the population of a small town is currently 8,250. So that's our initial amount. It has been increasing by 3%. So that's our clue that we're talking about growth. What will the population be in 10 years? Well, 10 years is going to be our T, our time. Okay. So what's our rate? Well, we have to take that 3% and convert that to a decimal. So if we have 3%, we're going to move that decimal 2 places and we get 0.03. So that is our rate. Then we're going to find our growth factor, and our growth factor is going to be 1 plus the 0.03. So then we have 1.03. I know it may seem silly, but a lot of students often make a mistake, or they forget to add the 1 and they just multiply by the 0.03. But that 1 is actually ensuring that you still are counting the initial amount that you had when you started off. So you have to have that 1. Now let's look for our answer. So we're going to plug it into our formula. Y equals 8,250, which is the initial amount. Okay. Our growth factor of 1.03. And we're looking for the population after 10 years. So to do this, we're going to do that all in the calculator at one time. So I'm going to go ahead and show you at least once. So give me just a moment while I pull open the calculator. Okay. So here in my calculator, I'm probably going to have to split the screen so we can see the example while we do it. So in my calculator, I'm going to do 8250 in both in your calculators in the classroom and on the computer has the parentheses. So we're going to put the parentheses 1.03. We're going to close the parentheses, and then we're going to use this X to the Y button because that's telling us it's an exponent. And so that's going to raise us to the exponent of 10. And then we hit equals and we get 11,087.31012. You get the idea. Okay, so now let's go back to our slides and get back to where we were, and you will see I have y is equal to 11,087.31. Now, remember that we're talking about people, and so because we're talking about people, we're going to talk about whole numbers. So we're going to round 11,087.31 to just 11,087. Oftentimes it will tell you where to round to, but if it doesn't, you're going to have to use some logic. And when we're talking about people, we're often talking about whole people. All right, in example 2, the starting salary at a job is $24,000. So that's our initial amount. The job offers an increase of 1.5% each year. How much will an employee make after 6 years? So first we're going to identify our rate. So we were given a percent, 1.5%. So 1.5% converts to 0.015. Then we're going to identify our growth factor. So we're going to add the 0.015 to 1, and we get 1.015. And then we're going to plug it into our formula to get our answer. So we have y is equal to 24,000, our initial amount, multiplied by 1.015 to the power of 6. So what you would do is in your calculator is you would type this all in all at the same time. So you could do 24,000 multiplication or parentheses 1.015 and then x to the y or y to the x 6. It depends on the calculator on how you would do it. Sometimes it's x to the y, sometimes it's y to the x. It means an exponent. So once you do that and you hit equals, you're going to get 26,242.6383. Now, in this particular example, we are talking about money. In money, we're always going to round to the nearest 100th. So our final answer is 26,242.64. So 64 cents. All right. Okay, we're now going to look at our check, and I do want you to try your check on your own. So go ahead and pause the video, see if you can get the right answer without proceeding or just looking at what I posted. All right, so our rate was 0.029. Our growth factor is 1.029. And so now we need to find our answer. Well, if we type that all into a calculator, we're going to get 1,052,135.59. Oh, wait, we're not talking about money. We're talking about population. So we're going to round that to 1,052,136 people. Okay. Look at what you're talking about. This is talking about population. It was not talking about money. So we're going to round to the nearest whole number. All right, exponential decay. So the only difference between growth and decay is that if we're dealing with decay or things depreciating, we're going to be subtracting our rate from 1. So everything else is the same. The only difference is now we are finding the difference, or we are subtracting from 1 instead of adding to 1. So let's look at our first example. Isaac bought a car in 2018 for $37,000. So that's going to be our initial amount. The car's value has been decreasing at a rate of 7% each year. So what you need to find is how much the car will be worth in 2024. So the rate is going to be your 7%, but remember, you have to convert that 7% to a decimal, so it's going to be 0.07. So our decay factor will be 1 minus 0.07, which is 0.93. And then we can use that to find our answer. So here's our equation. We have y is equal to 37,000, which is our initial amount, multiplied by 0.93, which is our decay factor. And that's going to be brought to what power? Well, we're not going to bring it to 2024 power. That would be crazy. Okay, so we actually have to look at what we're finding, and we're finding the difference between 2024 and 2018. So that's going to be to the power of 6. Okay, all we're doing is how many years is it between 2018 and 2024? It's 6 years. So once I plug that into the calculator, I'm going to get 23,938.6367. Well, we are talking about money, and because we're talking about money, we're going to round to the nearest cent or 100th place, which in this case would be 23,938.64. All right, last example for the video. A stock investment is depreciating at a rate of 3% per year. If the initial investment was $12,000, how much will it be worth in 10 years? This is definitely not a good stock investment if you're losing money, but in this scenario, let's just go with it. Oh, so that says 7%. I forgot to change my percentage. Please ignore that. It's correct down here. Look at this rate. The rate is 0.03. I just forgot to change that because I copied and pasted it from the other slide. So 1 minus 0.03 is equal to 0.97. So that's going to be my decay factor. Okay, this here is my decay factor. Now let's find my answer. So I'm going to plug in the 12,000, which is the initial amount. 0.97 is my decay factor, and I'm looking for the amount after 10 years. So once I plug that all into my calculator, I'm going to get 8,849.0895. And because I am talking about money, I am going to continue to round to the nearest hundredth. So 8,849.09 is what that investment would be worth after 10 years if it's depreciating at 3% a year. All right. I want you to go ahead and try the check on your own. It's about Detroit, Michigan. All right. Pause the video and then come back and check your answer. So Detroit, Michigan is experiencing a loss in population at a rate of 5.78%. So first thing I did was convert that to a decimal. So I subtracted that from 1 and I got 0.9422. And then I plugged that in to my calculator and I got 447,131. Now here I'm talking about people, so I am going to round that to the nearest whole number. So I get 447,131 people after 6 years of the population decreasing. All right, that's it for our notes. Go ahead and complete the practice in Canvas, and I will see you on Monday.